In last class we discussed about position vector and displacement vector. Today we'll start with localized and non-localized vectors. So localized vector, these are also called fixed vector, and non-localized vectors are also called free vectors. Localized vectors means the vectors which has a fixed point. For example, position vector. So I think you remember already that in a position vector, when we had drawn it, we started from origin. That means one point of the position vector is always fixed. We started like this. If this is the origin, this is the position vector, right? Position vector of a point P, suppose. So if this is the position vector, it starts from origin. So one point is always fixed. So that is why a position vector is a kind of, or is a type of localized vector or fixed vector. But non-localized vectors means where we do not have any fixed point. Suppose I have written the definition here, you can go through that. It does not have, or it do not have, a fixed point. These vectors can be displaced without changing its magnitude or and orientation. So that means, suppose here, if this is vector A, I can draw this vector A here also without changing the magnitude. Magnitude means you can see that the length of the vector is remaining same, and in fact its orientation is also remaining same. Orientation means if this is vector A, I cannot draw vector A like this. Like this means its direction will be different. But if I draw it somewhere here, then their direction is same. Okay, they are parallel. So that is why this will be the examples of non-localized vector. One example I have written also here. This one. For example, force applied on a wooden box to make it move horizontally. Suppose if we take a wooden box, this one, and if you want to move, suppose this is a horizontal surface, if you want to move this wooden box on this surface, you can apply the force here, you can apply the force here, you can apply the force here also, right? So the force is not in on a fixed point. So that is why it will be a type of what? Non-localized vector. Alright. Now suppose this non-localized vector, I have given some more example here. If this is vector B, we can draw this, we can shift, or we can take this vector B here also, we can draw it like this. If you see that their magnitude is same, means the length is same, and the direction is also same, they are heading towards this direction. Okay. Then vector C also we can draw it in this way. If this is vector C, we can draw a same vector C here also without changing the magnitude and the direction. Okay. Now in a vector there are two parts basically. One is the head, the other one is the tail. Head means this arrow part is the head and this part is the tail. Alright. Now let us discuss about angle between two vectors. So angle between two vectors means, suppose here we have two vectors A and B. Now always remember that they will make an angle either by their tail or by their head. That means in one point, the point where they are making the angle, that should be the point where both the tail meets or both the head meets. So if you observe this figure, and if you are asked to find out the angle between vector A and vector B, if you say that this is the angle, then this is not correct, because this is the angle made by the tail of A and head of B. But I said angle is always tail to tail or head to head. So what shall we do? The only thing that we can do is we have to shift A, either A or B. So I have shifted B here, and how we have shifted? Like this. B, I have drawn it first here, right? Then I have shifted it here. We can shift because in this chapter mainly we are discussing about non-localized vectors which can be shifted like this one. A, we have shifted it down. B, we shifted it here. C, we shifted it there. So in this way this B can be shifted here, and once we shift it, I have shown this one, this shifted vector here by dotted sign. Okay. So if you see now this angle, this will be the angle between vector A and vector B, because this angle is formed by the tail of vector A and tail of vector B. Okay. Similarly, you could have done this also. You can shift this vector A also somewhere. Instead of shifting this B, if you shift vector A here, here if you shift vector A, then which will be the angle then? Then this will be the angle, because this will be the angle between head of vector A and head of vector B. Okay, so that will be also angle theta. Fine. So here also you can see in this example, since vector A and vector B both are joined with one another, or they are in contact with one another by their tails, so that is why the angle will be this angle only, angle theta. Okay. Now addition and subtraction of vectors. So remember that, suppose, just an example, okay, I am giving you one example. Suppose a person is moving, a person has started moving from this point to this point, then suddenly he or she changed the direction and goes this side and finally reached to this point. So if you want to describe the motion of the person, you have to draw two vectors as I have drawn here. One is this vector and the other one is this vector, right? So I have given some name. Suppose this vector is vector A, this vector is vector B. Now which one will be the resultant? Resultant means, because the person started from here, and where is the end position of the person? This one. The person has followed this path and this path, but what is the result? Resultant displacement of the person. This is the resultant displacement, right, which is given by vector C. So in the word or in the language of vector, this C is the resultant vector. Result means it is the result of what? Of vector A and B. So in the language of vector, we write it like this: C is equal to A, C vector, okay, this sign is a must, you have to give this. Vector C is equal to vector A plus vector B, right? From this figure we can say this. But yes, of course, if A is equal to 2 unit, B equals to 3 unit, certainly A plus B is not 5 unit, because addition, vector addition is not same with the algebraic addition, because from the figure itself it is clear, right? If this is 2 and if this is 3, certainly C is not 5, right? So what is C then? In vector notation we write it like this. This is correct expression, but it does not mean that 2 plus 3 it has to be 5. It will be something different. Now how much it should be, how much the value of C should be? So for that we will find it out. We have to use some laws there, but before we go there, let us discuss first the subtraction part. Okay, addition already I told you this part, then subtraction. So subtraction means, suppose in the figure here I have drawn vector A and vector B. Now you are asked to draw vector A minus B. A minus, A plus B means, suppose if you are asked to do A plus B, in that case what shall we do? We would have shifted this vector B somewhere here. Okay, so A, B, and their resultant will be this one, C. This will be the resultant. But anyways, here we are not discussing about addition, we are discussing about subtraction. If it is so, what shall we do? Remember that A minus B, we can easily write it in this form, A plus minus B. That means ultimately what we are doing, we are adding only. Which two vector we are adding? We are adding A and minus B, not plus B, A and minus B. So where is minus B here? Remember, if this is B, just an opposite vector will be minus B. So this dotted line is giving us minus B. Alright, so this is A and this is minus B. Their resultant means, suppose if I represent it by C, then the resultant C will be somewhere here. And why it will be somewhere here, that one you will understand when we will discuss about parallelogram law. But for this time being, you just remember that addition, while doing subtraction, what we shall do, we have to take one vector as a, we have to draw a negative vector for any one. Like if it is A minus B, so first in the figure we don't have minus B, we have only A and B. So minus B you have to consider. How we will consider? Just you have to draw another vector in the opposite direction of B, that will represent minus B. Okay, and how the resultant we will find out, that one in the next topic only we are going to discuss. Okay, now here I told you this one, no, that how to find out C. One simple example I will give you. Suppose see here, if A is like this, Okay, if b is sorry if b is just perpendicular to it, here itself, here a and b are not perpendicular, right? But if it is like this, it may happen. If it is like this, then see, the resultant we can easily find out by Pythagoras theorem. If we know this is 2, if we know this is 3, then using Pythagoras theorem we can find out the hypotenuse, right? Okay, but here in this case it is not possible because it is not a right angle triangle. So for that we have to do we have to find out a much generalized equation. So that one we are going to find out. Okay, so in the next topic we are finding out this one. Anyways, before we go there, one small thing is there: properties of vector addition. Whenever we add two vectors like a plus b and b plus a, it is same only. This is called commutative law. In mathematics you may have got already, like 2 plus 3 equals to 3 plus 2, same only, right? In the same way, a plus b equals to b plus a. So vector addition follows commutative law. And another one, associative law. Associative law means something like this: a plus b plus c, where b plus c is kept in bracket, means, and that should be equal to what? A plus b plus c, means now a plus b is in bracket, so whatever term is inside bracket, we do the addition, we do that work first, right? So here suppose the thing is like this: 5 plus 2 plus 3, how much it is? It is 10, right? Instead of that, if I write like this: 5 plus 2, I am keeping it inside bracket, plus 3, isn't it 10? Again it is 10. So what is the meaning of this thing? Means first we have to do this part, means 2 plus 3, how much is that? 5. So 5 plus 5 is 10. But if I follow this equation, then I have to do first this part inside bracket. 5 plus 2 is 7, 7 plus 3 is 10. So both are same only, right? They are giving same result. So in vector also this formula or this thing is applicable. This is called associative law. Alright. Then very important topic of this chapter, laws of vector addition. So the first law is the triangle law of vector addition. So this triangle law of vector addition, if you understand this, easily we can find out the resultant that we got in this case, this diagram and that diagram is same only. Okay, anyways, so triangle law of vector addition means if two sides, this statement is like this: it states that when the two sides of a triangle represents two vectors in magnitude and in direction taken in the same order, then their resultant can be given by the third side of the triangle taken in opposite order. That means here you can see that this is vector A, this is vector B. They are these two vectors are given by the two sides of a triangle taken in order. Taken in order means if you see the order, A is like this, B is like this, so it is in order only, no? It is going like this, means it is in which direction? Anti-clockwise. So it is in same order. But instead of that, if I write that if I say that A is this side, B is this side, are they in order? No, A is going in clockwise direction, B is going in anti-clockwise. They are not in order. But in this particular diagram, they are in order. So that's what I have written: vectors in magnitude and direction taken in the same order, then their resultant can be given by the third side of the triangle, means which side? This side of the triangle taken in opposite order. So this, in for A and B, as I said, it is going in anti-clockwise direction, so C should be in opposite order, means in clockwise direction. So the direction of C should be like this. This should be the direction, means it is clockwise. Okay, fine. So that's what is said in this law. Suppose if I draw one vector like this, another vector like this, so what is the resultant? They are in same order and they are representing two sides of a triangle. So the third vector is like this. This is the resultant and its direction will be like this. Okay, not like this. If you give this type of direction, then see all the three vectors are in the same order, but it should not be, because the resultant should be in opposite order. That's what is mentioned. Alright, opposite order. In magnitude and direction means I have written everywhere, no, in magnitude and direction, that means it is representing both. That means this vector is representing both magnitude as well as direction. This vector is also representing magnitude, direction. This is also same. Okay. So that is the parallel, triangle law of vector addition. Next is the parallelogram law of vector addition. Suppose now we have two more vectors. One is vector A and the other one is vector B. So here vector A is given by one side of a parallelogram. Vector B is given by another side of the parallelogram. Both are in opposite order, right? Opposite order, and they are the adjacent sides of a parallelogram. If it is so, then their resultant can be given by the diagonal of the parallelogram. How it is the parallelogram? If you complete this side, then what? It is giving us a parallelogram, and the C is what? It is the diagonal of the parallelogram. Okay, so that's what is mentioned in this statement here. It states that if two sides, means adjacent sides, of a parallelogram represents two vectors in magnitude and direction taken in opposite order. See, they are in opposite order. A is this side, B is this side. But instead of that, if I say B is this side, then they will be in the same order. Means which order? Anticlockwise. Okay. But they should be in opposite order according to this statement. Then their resultant can be given by the diagonal drawn from the point of contact in magnitude and direction. So where is the point of contact? This one. So the diagonal should be drawn from here, and this will give the resultant of A and B. The same thing I told when I discussed about subtraction, vector subtraction. What I said here, here I told you that if this is vector A and if this is vector minus B, then what will be the resultant? Means C. What it should be? They are just two sides of a parallelogram taken in opposite order. So the resultant should be drawn from the point of contact like this. Okay, that is the diagonal of the parallelogram. So I think both the laws are clear. Now next topic will be, we have to find out the expression, means how much is the value of C and in which direction this C will lie. Because C, if it is the diagonal, if I say that the C is somewhere here, it is representing diagonal, right? If I say it is here, so it must have a specific direction, means it must make a specific direction with these vectors. Okay, so anyways we will discuss about it. That means how much will be the value of C and what will be the direction of C. Okay, so for that I have written something here that okay, the topic is expression for magnitude and direction of resultant vector. So here in this particular case, the derivation that I am doing, I am using this law, parallelogram law. But if you apply triangle law also, the same values you are going to obtain. I will tell you how. But first here specifically I am using parallelogram law. Alright. So here I have written that let us consider two vectors, vector P and vector Q makes an angle theta. They can be represented by two sides of a parallelogram. So certainly I am using parallelogram law. Their resultant can be given by vector R as shown in figure. So let us see the figure first. This is the diagram. Okay. So here is the diagram. Simple one, just you have to see the geometry. From geometry only we can prove it, not a difficult one, just you have to understand the geometry. So initially we consider two vectors, one is vector P, the other one is vector Q. How much angle they are making? Theta. This is the angle, theta. Okay. Now what we did is, I have shifted this vector Q here, that is BC. We can shift it, non-localized vector. And I have shifted suppose this P also somewhere at B, so that it forms a parallelogram. Now the resultant should be the diagonal as we know. So the diagonal is this one, R, vector R. I have given it by vector R. It is given by vector R. So OB is vector R. Then some construction is done. How? From B I have dropped one normal on D, perpendicular. and this point C, it is extended till D. Alright. Now if this angle is theta, then certainly this angle is also theta only. Okay. Then as we are finding the magnitude of R, this is the resultant, no? So we are finding the magnitude of the resultant, and in last case what I wrote there, C, no, I have written it like this, C equals to A plus B, but here the thing is what, in place of C it is R resultant, in place of A suppose it is P, in place of B suppose it is Q. So ultimately whatever be the name, we are finding the resultant. Okay, C, I told C, but here I have written R, same thing. So this resultant, how much angle the resultant is making with the vector P? Suppose this is given by alpha. Alpha is the angle made by this resultant R with this vector P. Here it is, alpha. Okay. Our aim is to find out R and alpha, because R is the magnitude of the resultant, alpha is the direction of the resultant. That means how much angle, direction means certainly in terms of angle we have to write. So how much angle this vector R has made with vector P. These two things we are supposed to find out. So first of all, we have taken triangle OBD. OBD is a right angle triangle. OBD. So if it is a right angle triangle, its hypotenuse is OB, base is OD, perpendicular is BD. So using Pythagoras theorem we can write OB square is equal to OD square plus BD square. Now see the diagram. OD means we can write OC plus CD. So OC plus CD whole square, and here it is BD square, given equation number 1. Then from the small triangle means BCD, from this triangle, suppose if you want to find out cos theta from this triangle, so cos theta means base by hypotenuse. So which one is the base here? CD is the base and hypotenuse is BC. Okay, so from this, just changing the sides, we can say that CD that should be equal to BC. CD equals to BC, given BC cos theta, given equation number 2. Similarly, from the same triangle again we are finding sin theta. So sin theta means perpendicular by hypotenuse. So perpendicular, here it is BD is the perpendicular, hypotenuse is BC. So I have written BD by BC. BD is equal to BC sin theta. This is given equation 3. So in equation 2 and equation 3 we got the value of CD and BD, which we are going to substitute in equation 1. In place of CD here we are supposed to write BC cos theta. In place of BD we are supposed to write BC sin theta. That's what I have done in this equation. See OB square, alright, OB square, OC is remaining same, OC. CD means BC cos theta, then whole square, plus BD means BC sin theta whole square. Okay. Then this is in the form, in place of OC, from the figure itself it is clear that from OC means it is vector P. So I can write here P. Since we are finding only the magnitude, so vector sign no need to give. So that is P. BC means, see from the figure, BC, as I told you that BC is nothing but equal to what? AO, because this vector Q is shifted to BC, right? So in place of BC we can write Q. So BC means Q, this one Q, then cos theta, then whole square, and this is also same, BC means Q, so Q square sin square theta. Now this is in the form A plus B whole square. We will break it like A square, P square, B square means this whole square means Q square cos square theta plus 2AB, like this. Okay, then this one, then what happened is, next step, from this term and this term, Q square we can take common, P square will remain as it is, Q square is taken common, we have sin square theta plus cos square theta, and then we have this term 2pq cos of theta. Sin square theta cos square theta is 1, so it gives us this value, P square plus Q square plus 2pq cos of theta is equal to R square. So but we need R, no? So if when you want to find out R, what we shall do? We have to take the square root of it. Means R is equal to how much? Square root of this value. Okay. So this is the expression for resultant. Alright. So after this you can write this line, r equals to root over this value, or if you keep this much also it's okay. Then next one, that is direction of resultant. Now to find out the direction of resultant, what shall we do? As I told you, direction means the angle, which is alpha here. That means the resultant has made an angle alpha with vector p, so we have to find out alpha. So for that, again we have taken OBD triangle, the small one, oh not small one, this one, big one, OBD. So in this triangle, tan alpha, tan theta, like tan of some angle, it is what? Perpendicular by base, right? So perpendicular, how much it is? It is BD, base is OD, so we'll write BD by OD. Then from equation 2 and 3 we can write, right? 3 means from equation 3, BD is BC sin theta. Then OD, OD means, it is, see the diagram, it is OC plus CD, OC plus CD. Now OC means, sorry, CD means from equation 2, CD means BC cos theta, BC cos theta, and OC is nothing but, how much is that? OC is P, so it is P, okay, and BC means it is Q, alright. So how much we got? We got tan alpha equals to Q sin theta by P plus Q cos theta, or alpha is equal to, alpha we need, so the expression is this one, tan inverse of this value. In this way we write. Suppose if you want to remove tan from this side, in this side we have to give one tan inverse, then this whole value will come like this, okay. So this is the final expression for alpha. So this gives us the direction of the resultant, and this gives us the magnitude of resultant. Actually r gives us the magnitude of resultant, alright. So these two equations, or these equations we can use to solve sums. Another very important thing, special cases, okay. So special case means, suppose if you are asked that, what is the maximum value of r? See, P and Q, suppose we are keeping it same, but maximum value of r resultant for two given vectors, it depends on theta, how the vectors are oriented. How it depends on theta? Because see, in maths you have already learned that the value of cos theta, it lies between -1 to +1. So whenever the value of cos theta is -1, certainly it gives us the minimum value, okay. So in other words, we can say that the resultant will be the minimum if cos theta is -1, and cos theta -1 means theta should be how much? 180 degree. So in other words, we can say that minimum resultant will be obtained if theta is 180 degree, and maximum resultant will be obtained, maximum means cos theta should be +1, and for cos 0 degree is how much? +1. So for maximum resultant, angle should be 0 degree, okay. So that's what I have written in the special case number 1. If the angle between them is 180 degree, that is antiparallel. Antiparallel means if one vector is this side, then the other vector is in the opposite side, antiparallel. So their angle is how much? 180 degree. They are called antiparallel. So 180 degree, then cos 180 degree will be how much? -1. And if it is -1, then from this equation what we can write? If cos theta becomes -1, then what it should be? P square plus Q square, then -2PQ, isn't it? So that's what I have written here. P square plus Q square minus 2PQ, it gives us P minus Q whole square. It's like A square plus B square minus 2AB. So if R square is P minus Q whole square, R will be what? P minus Q, which is the minimum resultant, because I told you already, minimum value of resultant will be obtained if cos theta is -1 or theta is 180 degree. Similarly, for maximum value, theta should be 0 degree, okay. In that case, it is parallel case. Parallel case means if this is one vector, then this is another vector. Suppose, what is the angle between them? They are parallel, so 0 degree angle, alright. Or if this is one vector, if this is another vector, just on it, then also same thing, the angle is 0 degree. So we call it parallel vectors. Okay, so for parallel vectors, in place of cos theta we will substitute cos 0. So cos 0 is 1, so here we are getting only 2pq. It gives us p plus q whole square. So r is equal to what? Only p plus q. So this is the maximum resultant. That means, suppose if we have two vector p and q, minimum value of the resultant will be p minus q. The smaller one should be subtracted from the larger one. Okay, smaller one suppose I have considered as q, and for maximum resultant they should be added, p plus q. So if you see this example, the thing will be clear. This one, say if the minimum and maximum resultant of two vectors are 8 units and 12 units respectively, find both the vectors. Suppose we consider that both the vectors are a and b. So according to this, minimum is how much? 8. And how do we get the minimum? Subtraction. That means a minus b is 8. And maximum how do we get? Addition. So a plus b is 12, because maximum is given 12. Okay, then just solve it. 1 plus 2 if you do, what we will get? This b will get cancelled, plus b minus b, it will be 2a equals to how much? 20. So a equals to 10 units. Units, because no unit is mentioned, it is only written units, so we will keep it as it is. Then substitute this value of a in either in equation 1 or in equation 2 to get the value of b, and it is obtained as 2 units. Okay, so a is 10 units, b is 2 units. So in this way we can solve different sums, taking this as a formula, this one, and then the previous two, this two also. This is another one formula, this is another formula. So this much for today. Thank you.